CMX Series SIP Solid-State Relays by Kratom. Welcome to the training module on CMX Series SIP SSR. Today's training outline consists of basic knowledge of solid-state relays, CMX Series overview, CMX part numbering, and CMX applications. Solid-state relays have been around for over 30 years. They were invented by Kratom engineers in 1972. A solid-state relay is an electronic switch made up of solid-state components. There are no mechanical contacts or moving parts inside the solid-state relay. This output switch is the key part of a solid-state relay. It is the component which does the work. AC output solid-state relays are normally powered by the AC line itself. This is accomplished by connecting the two gates of the output SCRs together through a controlled switch. This basic control is shown in the figure. When S1 is closed, the gates of the SCR1 and SCR2 are connected. Current from the AC supply flows through either R1 or R2 and into the gate of whichever SCR is forward biased. This turns the SCR on and the relay conducts. As long as S1 is closed, this action continues, reversing every half cycle of the AC supply. When S1 is opened, the SCR presently in conduction will continue to conduct until the zero current point is reached, and the SSR will be off. The SSR uses optical isolation to provide S1 function. There are two optical isolation methods to provide excellent isolation between control and output of the SSR. One is optotransistor circuit shown in Figure 2, and the other is optotriac control circuit shown in Figure 1. The optotransistor circuit requires less control current to operate, and it allows the manufacturer to modify the control circuit characteristics in terms of zero crossing voltage window, noise suppression, and other functions. The optotriac circuit generally requires a higher control current for satisfactory operation. Compared to electromechanical relays, solid-state relays have a few advantages. For example, when properly selected and applied, the solid-state relays have a limited life. Other advantages include no moving contacts to burn, stick, arc, or bounce, very low input current required, very fast response time, ability to switch at AC zero cross point or random, inherent characteristics of turn off at zero current point, no audible noise, and high surge current capability for several inrush loads. Solid-state relays have either a DC or AC control. For AC control, the AC signal is rectified and filtered to provide DC to the optotransistor or optotriac LED. In most cases, Kratom uses dual SCRs configuration as the output elements of its AC output solid-state relays. However, DC output solid-state relays are being used more and more widely. One of the major reasons for the use of solid-state relays for switching DC is the fact that there are no moving parts, no contact arcing, or wear-out mechanism. However, there are some precautions which have to be taken when using solid-state relays with inductive DC loads. Let's take a look at CMX Series solid-state relays for better understanding. CMX Series are high-power PC board-mounted DC output solid-state relays. They feature outputs with low on-state resistance, field effect transistors for efficient DC load control, 2500 volt AC optical isolation, logic-compatible DC control input, and industry-standard PC board mounting footprint in an epoxy package designed for full output rated operation at 40 degrees ambient temperature. In this slide, we list the products under CMX Series with their electrical specifications and part numbering guide. Because the input and output terminals of CMX solid-state relays are electrically isolated up to 2500 volts RMS, the relative position of the input signal and load connections are irrelevant. As shown in the figure, the input can be supplied either from a source or a sink configuration, and the load can be connected to either the relay positive or negative output terminals. The solid-state relay can be used as a level shifter because no electrical relationship is required between the control and power output sections of the relay. Due to the forward voltage drop, solid-state relays generate an internal power loss that is a function of the load current. To determine what an adequate heatsink system is for a particular application without going through the calculations, derating curves are provided for each specific solid-state relay that were generated using the specification data and verified through extensive testing. The derating curves can determine any of the variables that the system designer wants to deal with. The CMX DC output solid-state relays are ideal for heating, lighting and motion control applications in industrial, medical, aerospace, rail, and automotive applications.